Okay, so what we're going to do is we're going to do the notes for the energy of the electron. And to do that, this is the big section. The big section is the energy and the electron. But what we're going to talk about today is the relationship between wavelength and frequency in an actual wave. Now, yesterday we talked about, or last time we met, we talked about the fact that as wavelength increases, frequency decreases. And when we talked about that, we looked at the electromagnetic spectrum and we said, oh, radio waves, which are as long as a soccer field, remember I said that, as long as a soccer field, have a very low frequency. So radio waves have a low frequency, and gamma rays, which have a very high frequency, have a very short wavelength. So very short wavelength and a very high frequency, 10 to the 20th. So today we're going to look at how these two can be used to calculate the wavelength or the frequency of a wave. So first we're going to need the speed of light. So the speed of light is represented by the letter C, and that is 3.00 times 10 to the 8th meters per second. That is the units for the speed of light. So 3.00 times 10 to the 8th meters per second. We use the formula C equals lambda mu, and that's wavelength times frequency in a vacuum is equal to the speed of light. So this is the formula that we're going to use to solve for wavelength or frequency. And we're going to use the speed of light as the constant so that, again, as wavelength decreases, frequency increases because they always have to be equal to the speed of light in a vacuum. So let's start with the first example. So the first example is calculate the wavelength of a wave whose frequency is 4.5 seconds to the minus 1. So remember, frequency has a number of units that can be used. Seconds to the minus 1 is one of them. 1 over seconds is another one, or hertz is another one, and they all mean the same thing. So we're going to use seconds to the minus 1. We're eventually going to convert that into 1 over seconds. But let's take a look at the setup here. So we're going to start with our formula, which is C equals lambda mu. We want the wavelength. So let's solve for wavelength, which means that we're going to use a literal equation. This is an algebra 1 expression, literal. It means there is only letters. So you may remember, or maybe not, doing literal equations in algebra 1. It means there's only letters in it. So I'm going to divide both sides by mu. And when I do, I cancel the mu on that side. And so what I get is C over mu is equal to wavelength, which is nice because that is what I want, is I want to calculate the wavelength. All right, and I'm ready to go. So I'm going to plug in now 3.00 times 10 to the 8th, and my unit is meters over seconds, over divided by. My frequency is 4.5, and then I'm going to use the 1 over seconds here. And the reason I'm going to use that, that equals wavelength. The reason I'm going to use the 1 over seconds is because bottom and bottom cancel. And that's kind of a fraction rule. Top and top cancel, bottom and bottom cancel. And that's because if I were to actually do these out, I would multiply by the inverse. So I would flip this. So this bottom would come to the top. So ultimately, I would have meters over seconds times, and then I would flip this, and I would get seconds over 1. So I would be able to cancel. So bottom and bottom cancel, and top cancel. All right, so now I'm going to use my calculator. Okay, so I'm going to get 3e8 divided by 4.5, and my answer is, I need to put it in scientific notation. (6.7) times e to the 7, and that's the answer. So 6.7 times 10 to the 7, and my units is meters, which is great because I'm looking for a wavelength. All right, so let's do the next one. A radio broadcasts with a frequency of 107.1 megahertz. That's what that M is. Mega, as in mega 10 to the 6th. Go to your conversion list. What is the wavelength of the broadcast? So I'm still looking for wavelength. So wavelength from up top here is equal to c, which is speed of light over mu. Now the thing is that the speed of light is equal to, this is megahertz, and I need hertz. So I've got to convert that, right? So I get 107.1 megahertz, right? And I need to convert that to hertz. So megahertz goes on the bottom, and then 10 to the 6th hertz goes on top. And now I'm going to use my calculator to convert that. 107.1 times 1e6, and that equals 107.1e8. So 1.071 times 10 to the 8th. Hertz. Okay, and now I'm ready to go. So I have to convert that before I can do this. So now I'm ready. Wavelength equals 3.00 times 10 to the 8th meters per second over, and now I'm going to do my frequency, 1.071 times 10 to the 8th hertz, which is 1/2. And that's what I need to use here so that I can cancel out my seconds. 1/2. And I cancel my seconds so that I get meters again, because that is equal to wavelength, meters, because I want it in meters. So I'm ready to do my calculation. Let's do that. 3e8. And I get 2.80. That's it, just 2.80. So 2.80, and my unit is meters, and that's my answer. Now, just so you know, if you have to calculate frequency, then you have to do your literal equation again. So you're going to have to take your C equals lambda mu, and you're going to have to solve for frequency, and then plug in your wavelength with the unit and solve for the units that way. Okay, that's it.